Okay, in 4a, you're asked to use implicit differentiation to prove that the derivative of y with respect to x of arctan x is 1 over 1 plus x squared. And I do want you to draw the triangle so that I know that you're interpreting this notation correctly. So y equals arctan x means that y is the angle whose tangent is x. Another way to say that is x is equal to the tangent of y. Once we do it this way, when we rewrite it by solving for x, then we're unable to take the derivative directly. Therefore, we have to take it implicitly. So let's take the derivative of both sides with respect to x. So the derivative of x is 1, and then the derivative of tangent is secant squared y, and then the derivative of the y with respect to x is dy dx. So then I'm going to use algebra to solve for dy dx and get 1 divided by the secant squared of y. Well, now this is where we really need to use the triangle again, because we want to say, well, what is the secant squared of y? So the secant, again, is 1 over the cosine. So we need to figure out what the cosine is. Well, the cosine is adjacent over hypotenuse. So the cosine, in this case, we're going to have to use Pythagorean theorem in order to determine what the length of the hypotenuse is. So doing that, we get x squared plus 1 is equal to h squared. So h is equal to the square root of 1 plus x squared. So now back to this part here, we're trying to determine what the secant squared of y is. Well, the secant is 1 over the cosine. So we have 1 over 1 plus x squared, which turns out to be 1 over 1 plus x squared. In the second part of the question, I said that the graph of the arctangent is shown. Explain how the formula for the derivative aligns with the graph, i.e., where is the function increasing or decreasing, and how does this relate to the formula for the derivative? We found several really outstanding answers. Here's one of them. She says, or he says, that the function is always increasing, and we can see that as you go from left to right when the x values start negative, approach 0, and then go towards positive infinity. The function is always increasing. So that means that derivative is always positive, which right then and there is terrific. That's exactly what we were looking for. She or he goes on to say that the formula for the derivative is 1 over 1 plus x squared. Therefore, when x is 0, the function is increasing at a rate of 1 to 1 over 1, which is 1, right? Because if you put 0 in here, you're going to increasing at a rate of 1. And you can see that all in through here, the function is much steeper. The slope of the tangent lines are going to be much steeper. Then the person goes on to say, however, when it is less than 0, it meaning x, it is increasing at a growing or increasing rate. So again, we can see that if we were to imagine drawing in these mini tangents, they would get very positive quickly just here, but they're always increasing. And at a growing pace. And when x is greater than 1, so now we're on this side, the slopes of the tangent lines, and hence the equation for the tangent, for the derivative, approaches a limit of 0. In other words, these tangents, the slope of those tangents, are increasing at a slower or dying pace. So that's the end of the videos. Please write any reflections or insights that you gain when you answer each of these questions.